Okay, so question A want us to determine the speed when it hit on the ground. Okay, so we know v final square minus vi square over 2g is equal to the height h. V final is the speed when it hit on the ground, which is the final speed for this free fall motion. Vi is the initial speed. Okay, g is the acceleration of the gravity. And since at the beginning it was at rest, there's no initial speed at the beginning. Okay, so it just can simply equal to v final square over 2g is equal to h. And therefore v final is equal to square root 2gh. Okay, which is equal to square root 2 times 9.8 meter per second square times h, which is the height, which is 12.0 meter. And this will give us the speed when you hit on the ground is about 15.34 meter per second. Okay. And for question B, you want us to determine the average force of the air resistance when the speed when you hit on ground is about 8 meter per second. Okay. So well, we know the speed when you hit on the ground, which is the v final of this free fall motion, can be equal to at, which is acceleration times time, since there's no initial speed, which is simply equal to 8 meter per second. And from the last equation, we'll have v final square over 2a in this time. Why is that? Because there's air resistance involved in question B. Okay, so the acceleration is the net acceleration due to the air resistance and the gravitational force. Okay, and this is also equal to the height of h. There's no vi here because still initially there's no speed, so initial speed is 0, so just v final square here. Okay, and then we'll have a is v final square over 2h. Okay, and then we'll have, remember v final was 8.0 meter per second, so v final square is 8.0 meter per second, and then whole thing square. Okay, and then over 2 times h, which is 12.0 meter. Okay, and this will give us the acceleration is about 2.67 meter per second square. Once we got the acceleration, we can determine the net force during this free fall motion, which is F net equal to ma. If we plug in the value, we have 0.145 kilograms, because 145 grams is 0.145 kilograms times 2.67 meter per second square. And then we'll have 0.3875 newtons. Okay, this is the net force. But remember, net force can be equal to, in this case, the gravity minus the air resistance force. Let's use lowercase f to stand for it. Why is that? Because if you take a look at the motion, it should look something like this. Since its net direction is going downward, that means the gravity is larger than the air resistance. Okay, so gravity here, and the air resistance is here, and the whole motion was going downward since the gravity is greater. Okay, and this will give us the air resistance. The force of air resistance is equal to G minus F net. which is mg minus Fnet. If we plug in the values, we'll have 0.145 kilograms times the acceleration of gravity, which is 9.8 meter per second squared, minus 0.38715 newtons. Okay, and this will give us the force of the air resistance is about 1.03 newtons. Okay, and this is the answer for the question. Thank you.